Alright, Jim, back 2 times in one day because we now have the positive exponent decoding working fully. So just for an example, 2 to the power of 11, the exponent is decoded as 1011, which is 11. 2 to the 125, which is 2 shy of the highest exponent, is, as you would expect, the first bit. This is positive exponent decoding, so it's always going to be 0 for the sign. 2 to the 126 is 1 shy of 2 to the 127. Bada bing, bada boom. And so I was explaining earlier, the problem I was having was I couldn't tell these numbers apart because I keep on carrying over into each next chip, the exponent from the previous chip. So because these are all 1s, then this exponent, 2 to the negative all of these, gets carried over into the last chip and it gets halved. But for this specific value, that ends up being 2 to the minus 127, which is 0 on this game. So how I resolved that issue was changing the order of multiplication. You'll see that the inputs to these AND gates are the same 3 things, but they're in a different order. So if we if we plug in 2 to the minus 1 and 2 to the minus 126, they multiply by each other and become 0 because the game, that's an evil number. And then when they're supposed to multiply by this and cancel out, instead it multiplies 0 by that. But if we plug in this first and then multiply it by 2 to the minus 126, that'll be 2 to the 1, which is 2. And then we multiply it by 2 to the minus 1. Then it does cancel out and the result is 0. So for the last chip, I just changed the order of multiplication. I plugged in, I halved the input number, 2 to the 127 in this case. First I halved that, and then I multiply that by this carried over exponent. As long as this carried over exponent is at the bottom, then it won't multiply by this small number first and result in a 0, and it can actually cancel out and result in a 1. Yeehaw.